Okay, so now let's see the question in your attendance problem. It's the attendance problem in your in calculus. Okay, so let's see. It's about the material in chapter in section 11.5. It's about a chain rule. It's about a chain rule. So W is a function which contains three variables x, y, z. So W, the function W contains three variables. So W contains three variables x, y, z, x, y, z. And for the variable x and y, x, y, and z, they also all of them also contain two variables r theta, r theta, r theta. So now we can see a partial w, partial r, and partial w, partial theta when r equals 2, theta equals pi over 2, right? Okay. So for the function w, it contains three variables x, y, z. And for all of the variable x, y, z, they also contain the variable r and the theta. So now we can see the partial derivative, this one. So we could use the chain rule. And then we use the chain rule, then when we use the chain rule, you should check each term. I mean for the for the function w, you should consider its partial derivative by x, by y, and by z. So first of all, of course, you should consider wx. So wx, then it means that you consider its partial derivative by x. So we view yg as a constant. So it's constant. So this part is constant. So just keep it. So its derivative. This guy is derivative itself. But you also need to multiply by inside its derivative. So 2x is derivative is 2. So first term is this one. First term is this one. And the second term, x is a variable. So this part, they are constant. We could view this guy as a constant. So constant will keep it. S is variable, its derivative is 1. So 1 times this constant. So it's plus 3 times 1 times exponent negative g. Second term. And the last term, x is the variable, view yg as a constant. So it's constant is derivative is 0. Constant is derivative is 0. So it's this one. It's this one. And we could write down wy, wg, each term, right? And wy, so now variable is y, so we view xg as constant. So this part is constant, keep it. Y is derivative to 1, so it's 1 times constant. So it's 1 times constant, this one. And second term, now mu x and g as constant, so all of them are constant. Constant is derivative 0 plus 0. Next term, this term is constant, keep it. Exponential negative y, this term is derivative itself. So keep it, its derivative itself. But inside this term, you also need to multiply by inside its derivative. So negative y is derivative negative 1. This one. The last one, the partial derivative by g. So view xy as constant. So it's constant, its derivative is 0. And next term, 3x is constant, so keep it. This term is derivative itself. But inside you should consider its derivative. Its derivative is negative 1, so multiply by inside negative 1. And the last term is constant for this part. Variable is g. This part is constant. Constant times g is derivative 1, so it's 1 times the constant, this term. Okay, yeah. So here it is equal to 2y exponential 2x. And then it's equal to exponential 2x subtract g exponential negative 1. And then it's equal to negative 3x times exponential negative g plus exponential negative 1. This one. Okay, and when we should use chain rule, and for r theta, we also, so for the variable x, y, z, we also need to consider its partial derivative by r or by theta. So here we consider xr, this one. xr is so now consider its derivative by r, then theta is view theta as a constant. So it's constant, so its derivative is 1. 1 times constant, so it's sin theta. And another one is senior. yr is derivative cosine theta, g r is derived by the variable r, then we just have the constant theta, right? And we still have another variable theta, so we consider x theta. X theta means that consider partial derivative by theta. So partial derivative by theta, so r is constant, keep e. Sin theta is derivative cosine. Sin theta is derivative cosine. And y theta. Y theta, then now r is constant, keep e. Cosine is derivative negative sine. So negative r sine. Negative r sine. And the last one, g theta. R is constant, keep e. Theta is derivative 1, so it's r times 1, so it's r. So it's r. This one. This one. Okay, so now we could use the chain rule. We could use the chain rule. Use chain rule. First one, we know that WR, partial W, partial R. The notation partial W, partial R also means this one, right? Also means this one. And it's equal to WX times XR plus WY times YR. YR plus WG times GR. This one. Okay, that's the notation. You could view it this way or this one. It's the partial W, partial X times partial X, partial R. That's the notation you could denote. You could use it. You could use this notation or this one. This one. It's just a notation. It's just a notation. This one. Okay, but now we still have one problem. Now we want to plug in the value r theta 2 and pi over 2. But when we plug in the value Ws is this one, Xi is this one. But when we plug in the value r and the theta, this part is related to x and y and yg, right? So you should know when r equals 2, theta equals pi over 2, you should know its corresponding SYG value. It's corresponding SYG value. So when r theta equals 2 pi over 2, what's the SYG value? SYG value becomes first one, this one, 2 times sine pi over 2. Next term, 2 times cosine pi over 2. The last term, 2 times pi over 2. This one. So this one is sine 90 degrees, so it's 1. Cosine 90 degrees is 0. And it's pi. So finally, its value is 2 times 1 is 2. 2 times 0 is 0. 2 times pi over 2 is pi. So SYG value is this one. SYG is this one. Okay, so now we could plug in the value. Then you will get it's partial W, partial R equals the first term Wx is this term and the SYG is this term, this one. But when you plug in the value, you will see y equals 0, so this term is 0. For this one, it's 0. And once it's 0, so this term is 0. First term is 0 originally. And 0 times any one, it must be 0. This term is already 0. And this one, W1 is this term. And in this term, S is 2, so this term is exponential. 2 times 2 is 4. Subtract g pi, subtract pi times exponent negative 0. This one is our wy times yr is this one. So cosine pi over 2. But cosine pi over 2 is cosine 90 degrees is 0. So this term yr when r equals actually cosine theta, when theta equals pi over 2, this term is 0. Yeah. Actually, we could denote it when theta equals pi over 2, it's 0, and here when y equals 0, it's 0. So when you consider Ws or yr, it must be 0. So this term is 0, yr is 0, so multiply by 0. So we just need to consider this term. Since it's 0, it's 0. It's 0. Okay, so this term, this one, so it's equal to negative 3 times 2, so it's negative 6 exponential to the power of negative pi plus exponential negative 0 times GR. GR is this term, and GR theta is equal to pi over 2. Pi over 2, this one. And finally, this one is exponential negative 0 is 0. So exponential 0 is 1. It's 1. So it's 1 subtract 6 exponential negative pi times pi over 2 times pi over 2 times pi over 2. It's the first one. Times pi over 2. Let me see. Is something wrong? Oh, sorry. Here is 2y plus 3 exponential negative g. Yeah, sorry. It's not 0. Sorry. So it's equal to this part is, oh yeah, this part is 0, but we still have this 10, so it's 3 is going negative pi, sorry. So this 10 is not 0, sorry. So partial w, partial r equal, the first 10 is 3 exponential, 3, this 10 is not 0, sorry. 3 is going negative pi times xr. xr is this 10. 3, yeah, xr sine pi over 2. So it's sine pi over 2 is 1. So it's 1, this one. So this 10 we still have, but this 10 is 0 is correct. And this 10 we still have 3 exponential pi. So finally it's 3 exponential negative pi plus 1 subtract 6 exponential negative pi times pi over 2. This one. This one. Okay. And the last one is partial w, partial theta. It's w theta. So again, chain rule. W is the function contains syg. So here we have wx, wy, wg. But for all the value function syg, they are relative to theta, right? And we can see w theta. So it multiplied by x theta, multiplied by y theta, multiplied by g theta. And chain rule, so we should consider their sum. So it's called chain rule. It's called chain rule. So and again, when r theta equals 2 pi over 2, then partial w partial theta equals 2 pi over 2. So first one wx, wy, wg. And here, oh yeah. So ws is this 10, 3 exponential negative pi. But now x theta is this one. And the x, okay, so now let's see. Theta equals pi over 2. So cosine pi over 2 is, cosine 90 degrees is 0. So this 10 is 0. And this 10 sine pi over 2 is 1. So this 10 is negative r. This 10 is negative r. And this 10 is r, yeah. Anyway, so this part is 0. So when you see x theta is 0, so this 10 it must be 0. So you could, yeah, multiply by 0. And wy, let me see, yeah, no. And wy is this one. So just plug in wy. Actually, wy is this one. Just keep it, just can see, write it down. Let me see, yeah. And exponential to the power negative 0 is exponential 0, and it's equal to 1. It's equal to 1. So it's equal to 1, so we could skip it. Equal to 1, so we could skip it. It's 10. Multiply y theta is this one, so it's negative r, so it's negative 2. So it's negative 2. Plus wg is the value, this one. 1 subtract 6 is going to the power negative pi times g theta is this one. And the r is 2, so it times 2 is 2. And this 10 is 0, this 10 is 0, so we just have these two 10s, their sum. So finally it's equal to, yeah, so just the solution, just their sum. Negative. Okay, so that's all. Yeah, that's all. That's fine. That's all. Yeah, so it's the problem in section 111.5. It's about a chain rule. Okay, so now let's consider the attendance problem in section 11.6, directional derivative and tangent plane normal line. For tangent plane normal line, actually you just need to follow the formula. Yeah, and actually for directional derivative, you also just need to follow the formula. So as you see, okay, let me tell you the question. The first one is, we let xyz be the function xyz, subtract x times natural log subtract x times natural log y plus y times natural log x. So first of all, we find the rate of change. Rate of change means the directional derivative. Rate of change of f at p 113 in the direction to Q231 Second one, find the maximum rate of change. Find the maximum rate of change. Find maximum rate of change. Of f at a point P 113 and the direction in which it occurs. Yeah. Okay, so let's see the first question. Okay, so let's see the first question. Which one? This one. Okay, so let's see the first question. Find the rate of change. Rate of change of f. It also means directional derivative. It also means directional derivative of f. Okay, so first of all, we want to know the directional derivative of f. So du f of 113. We want to know du f of 113, but we want to know du f of 113. Okay, and then if you want to know the UF of 113, we should use the formula the UF 113 is equal to gradient f 113 and U their inner product. It's a vector in R3 and it's also a vector in R3, and then for this vector it's a unit vector. Gradient f 113 we have what does it mean? It means it's a vector in R3, and the first component is partial derivative by x, and we plug in the value 113, the point 113, and fy 113, fg 113. This one is gradient, and the inner product, this vector and unit vector probably ABC. Okay, in which direction? And at this point in this direction to this one, so we have the direction PQ, right? So we could write down. And anyway, so first of all, we should consider this one, partial derivative. So let's read what we say. Almost all equation in this section, the first step you should consider is to find its partial derivative. Okay, so we should consider its partial derivative, gradient f, and it's equal to gradient f. The first component is partial derivative by x, partial derivative by y, partial derivative by g. And first one is, okay, so now first term, consider it's derivative by x, then uyg as a constant. One constant, so it's derivative with 1. 1 times yg, so it's just yg. And the second term is derivative, so natural log of y is constant. Constant times x is derivative 1. 1 times natural log of y, so you subtract natural log of y.